I'm so glad that everyone could make it today. I'm telling you, this night is a treat for me and I think for all of us. What we have, and I'm going to introduce him in just a minute, we're talking about from Finches to Hawking, giving voice to the brain's whisper. You know that I'm Sharon Anderson-Morris. I'm managing director of Fire Films. I'm director of programs for the Strategic New Service and for our Fire Conference coming up in October here in Park City. It is our honor to be able to connect with technology leaders that are really doing things in the world, and one of the most brilliant and most enjoyable speakers that I think we've had so far is Dr. Philip Lowe. Philip Lowe, would you please come in? And close the door. Have a seat. Philip he knows everything about the brain. He knows about the human brain, about the animal brain, and he is also very intuitive as well, which is the gift that I've had today with just spending some time with him is one that I'll never forget. We did educational outreach today, and the students were just mesmerized about what he had to talk about with animals and human behavior and what's really happening in the brains of people with ALS and Alzheimer's. And for the first time ever in student outreach, some kids asked him for his autograph. So that's how good he was for students, I mean, for an hour and a half. So I'm delighted to have you here tonight. And I'll tell you a little bit about Philip Lowe. He was an honored speaker at our Fire Conference last year. He was one of the speakers that people came to me and said, I want to see him again. He taught me more than I've ever known ever. And these are really, really smart technology leaders. Total hit at our Fire Conference. He's also the chair, chief scientist, and CEO of a company called Neurovigil, which he started by the age of 30. Yeah? 27, sorry. 27. As a graduate student. He's an inventor, neurotechnologist, computational neuroscientist. He's responsible for creating with his team something called the iBrain, which is about this big, which is a portable EEG device instead of the MRI machines where you have to go into and lay down and you're dot, 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 dot. It's this big, put it right here, and he can measure the EEG of humans and animals. Amazing, huh? He created, with a couple of others, the Cambridge Declaration of Consciousness, which recognizes the overwhelming neurobiological similarities between humans and animals. And he'll talk about that. He brought that as well to the Pope, to President Obama, and to the Dalai Lama. He's not messing around. So a little bit of background about this really amazing man. When he was 10 years old, his father had a drug reaction, a violent drug reaction to a pharmaceutical drug, and he was incarcerated. This will come up during our conversation tonight, just something for reference point that you should know. The body of his PhD thesis is one page, the shortest thesis ever in history. He held dual appointments at Stanford and MIT before the age of 30 years old. His company's team, Neurovigil, consists of Elon Musk, Irwin Jacobs, the founder of Qualcomm, Stephen Hawking, and many other Nobel laureates. And so now I get to ask him some questions. And you will too, when we're done with this, we'll have Q&A. Stephen, welcome.
Thank you very much. Thank you, Sharon, for organizing this event.
I'm delighted to have you here.
Delighted to be here. Thank you to all of you for being here and for supporting this event. We look forward to being here tonight and to your questions.
So how did you become interested in the brain?
Well, I always thought I would be a theoretical physicist. And after studying things that didn't exist or that were inert for about 2 years in college, I was forced to take some biology courses. And all of a sudden, that was something that was very refreshing for me, to study life, but through a quantitative prism. And I came up with all kinds of models. There was one particular molecule I was very excited about. And I ended up being told by the faculty, listen, you're a nice kid, but why don't you go back to mathematics? We don't need quantitative theories about how tumors become metastatic or anything like that. So it turns out that Chicago had forgotten to remove my email from a mailing list. And Harvard wanted one student from Chicago to come to Harvard for a summer program. And I just decided I would send my little theory and see if there was an interest. And sure enough, to the great dismay of my professors at Chicago, they picked me. So I went to Harvard, discovered that a particular drug had an anti-proliferative effect for certain tumors. And I thought that studying life was really very refreshing. So, but I found out that even at a wonderful institution like that, I was looking for more quantitative approaches. And so there was a new field called Computational Neuroscience, which was extremely exciting because it looked at what is, in many respects, the final frontier, the brain, but through the prism of mathematics, physics, computer science, chemistry, etc. And I took some graduate courses in there, and then I had to make a choice between molecular biology and neuroscience. So I thought, even though I was leaning very strongly towards the brain, that I would send a note to somebody who knew a little bit about both. He knew a little bit about molecular biology because he discovered DNA, or co-discovered it. And he knew a little bit about neuroscience because he was running a neuroscience program at the Salk Institute. And so I just sent him a letter by registered mail. His name was Francis Crick. And about a week later, I got this little slip in the mail, and he hadn't signed it. The post office at the Salk had signed it, and I thought I'll never hear from him. And sure enough, a week later, I received a full letter from Francis telling me that, because what I did is I wrote my wildest ideas in molecular biology and my wildest ideas in neuroscience. And I just told him, which one is the least unpalatable. And so he said, you need to come here and do neuroscience. And so I turned him down because I thought I wasn't ready yet. I hadn't asked for an invitation from him, but just for some guidance. And I gave myself a year to really look at neuroscience from the perspective of somebody in a laboratory that was in Chicago. And then when I felt that I had paid those dues, I took a one-way ticket to San Diego and turned that into my vocation.
Okay, so let's talk about the eye brain and humans. Tell us what the eye brain really actually is, and what does it detect in humans, and how is that useful for your research?
Sure. So it turns out that about 100 million people in America have a central nervous system disorder. It doesn't necessarily mean that they have symptoms yet, and it is estimated about 2 billion people worldwide have a CNS disorder. That's a huge problem because usually in this field we will react to problems once a person has symptoms. Now we have 100 billion neurons in our brains. If we're going to wait until a person gets up in the morning and can't see half of his or her face, then that means that many different layers, many different redundant networks have already been disrupted. And because there's very little plasticity in the brain, in other words, the brain's ability to repair itself in the adult stage is limited. It is existing though, but it is limited. It means that we are not helping the people in a way that we could. So what I decided when I was in grad school, I had this other unpalatable idea, which was that perhaps instead of waiting until people had symptoms, we could just monitor them. And instead of bringing them to a hospital and putting them in an MRI machine, we should just scan their brains in a completely novel way. And the idea is, can we use sleep in order to scan people's brains? So in the very back of our brain, we have this thing called the brainstem. And it has projections all over our brains. And it squirts neurotransmitters on these different areas. Now, neurotransmitters, it's just a fancy name for molecules that the brain uses to talk to itself. And when we're awake, all of these different neurotransmitters, norepinephrine, for example, serotonin, glutamate, all of this, they're all turned on. But when we're asleep, we have, depending on which sleep state we're in, different concentrations of neurotransmitters that are being suffused throughout the brain. So I thought, given that that brain structures have different concentrations of receptors for these neurotransmitters, maybe we could monitor people while they're sleeping and create maps of brain activity. So during my PhD, I'd created an algorithm that takes a single EEG, brainwaves, and sort of gives us some information about these brainwaves that was not previously known. So now that this information was available, I thought, well, we can build a tiny little monitor. That was iBrain. And we launched it in 2009. And we've helped some of the world's biggest pharmaceutical companies conduct clinical trials from the homes of patients. Initially, because we bootstrapped this company, we were so broke that we didn't have a budget for the boxes in which the iBrain would fit. So the first iBrains were delivered in Tic Tac boxes.
Really?
Yeah, Tic Tac boxes. They fit in there. The iBrain 3 fits in a tiny little Listerine packet. So we've sort of graduated from one level of dental hygiene to another. But
you needed a marketing person to help
perhaps. But it was quite funny. When I told this to the founders of Google, they were laughing because they said that their first racks were with Lego chips, you know. So they said Tic Tacs, Legos, you know, it has an authenticity to it. So the iBrain 1 was used to do that for these clinical trials. We have an iBrain 2 that senses information from not just the brain but other organs as well. And then we have the iBrain 3, which is a tiny little device which NASA has requested to be sent to the space station so that we can monitor astronauts while they're floating around.
Do you want to do that again? Did you hear what he said? The iBrain 3 is going to go to the International Space Station to monitor astronauts as they're floating around.
Yeah. So this will be the first out-of-this-world clinical trial, literally. Yeah.
And what are you monitoring for the people in the space station?
Well, so I understand you're taping this, so I've got to be rather circumspect. But let me put it this way. When a person takes an aspirin, for example, or any type of drug that affects them, if they take another drug, let's say, an antidepressant, for example, when you combine two drugs together, it is not actually a rational assumption to make that one can predict a person's outcome based on the individual responses to both drugs separately, to each drug separately, because drugs will actually interact with one another. And so we can't possibly test astronauts for every possible drug combination they may take. But what we can do is we can record from them while they're up there. We can also record from them while they're awake and they're doing a spacewalk, which is actually extremely demanding on the body. And astronauts are some of the finest people we have in this country. They take tremendous risks and they're extremely well trained, and just like our servicemen and women. And sometimes, if we ask them how they're doing, they will say that they're fine. They have another 5 hours in them, when in fact, they're not doing so well. So it's important to have objective metrics that we can use so that we can monitor these people while they are, manning the most expensive piece of machinery humanity has ever built.
So are you going to measure their brains before they go and then compare as they're in the International Space Station?
And we'll measure while they're up there.
Right.
Yeah.
So you compare what happens to the brain while they're up there.
Right. So there are all kinds of discussions that are going on right now. But so far, in terms of iBrain, it's been deployed for pharmaceutical trials. We've done a number of studies on autistic children, children who have Down syndrome.
Yeah.
We have done a lot of work pro bono for ALS and Stephen Hawking and ALS sufferers. This is a waking application of iBrain to enable individuals to communicate just using their mind. And now we did something that's a little bit strange. we announced that we were going to put this technology on about 20,000 seniors next year and run the biggest clinical trial in history. So the whole philosophy behind iBrain is that instead of turning people into pincushions and really disrupting them and making their lives restrictive, we want them to do what they do normally without having to go to a hospital. And we just want to be there and monitor everything. And if we do this with a large enough sample, then we may actually find particular environmental factors that may actually be nefarious or very, very positive, especially as some people may transition from MCI, mild cognitive impairment, to full-blown Alzheimer's.
Right, so which is really interesting. So you're going to be taking 20,000 people that are not yet developing Alzheimer's, doing brainwave monitors with the iBrain, so that we can actually research to show how it progresses within the brain, to educate ourselves for preventative purposes, for understanding how the whole process works, so that we can actually better identify and treat, right?
Absolutely. Alzheimer's is a $100 billion problem per year now in the United States at least, and this is excluding any research. It is projected to become a $1 trillion problem. In California, people are getting it younger because so Alzheimer's incidence is increasing faster than we are aging. So there is an entire tsunami in the horizon, and we just need to really prepare ourselves. I'm a data activist. I think that if we can actually get enough data from enough people, that is our best shot, as opposed to just completely ruining the lives of certain people by putting sensors all over them and then acting surprised that the data is not very convincing.
Right. Do you want to talk about ALS?
Sure. So I had the.
Does everybody know what ALS is? Lou Gehrig's disease.
So basically, it's an awful condition. So raise your hand if you know who Stephen Hawking is. Okay. You've seen the movie? I haven't seen it. I hear it's great. And so the affliction that Stephen is battling is called ALS, even though in his case it's very, very rare, because traditionally, once a person has been diagnosed with ALS, one has on average about 1,000 days left. In fact, I was asked to give the keynote at the Brain Tech conference in Israel a little while ago, and this gentleman appeared on stage and didn't say anything. And then there was a video behind him, and he had actually taped his comments a few months prior because he was not sure if he would be alive for the conference. And this is the type of anxiety that one has to live with, and over time one loses the voluntary control of one's muscles. So it is an extremely dehumanizing disease. There are different types of ALS. One is called bulbar ALS, which is not what Stephen has, but it sort of moves down, and the last limbs that you control are your feet. And in fact, there's a gentleman we work with by the name of Arguinedo who has that type. But it is a very tough disease. And so during my first year in college, I had the opportunity to meet Stephen Hawking. So 17 years old at the time, and I never thought that 15 years later I would be monitoring his brainwaves. So what happened was that a few years ago, I had to give a lecture at GSK, which is a big pharmaceutical company headquartered right outside of London. And Stephen knew that I was coming to England, and he asked me to visit him. And we were in his kitchen, and he was with his loved ones, and he has a wonderful team helping him. And he was trying to say something to me, and it took some time to get there. And eventually, after about half an hour, he said, his synthesizer said, "Hello, Philip, thank you so much for coming, good to see you." And I thought, one of the most brilliant minds that we've ever, that humanity has ever produced has to work half an hour to be polite. And so he wanted to know if, given the technology that we had developed at Neurovigil, the hybrid technology and the algorithms that I developed before and since my PhD, if we could actually develop a system that would enable him to bypass his body entirely. Mm-hmm. And so I said, well, look, I'll try, but we have two conditions. And I said this earlier this morning, I'm a fan, but I'm not a groupie. So it's very important that this is not just for you, but that this really helps other individuals who suffer from ALS. And the second thing is, we want your feedback. We want to make sure that we have a direct line of communication. And so he agreed to that. And I asked him when he wanted to start. He said right away. And so I recorded some brainwaves from Stephen Hawking in his kitchen. A few months later, we had Helena and Luke, and I'll show some slides, who did a longer recording. And then we ended up analyzing this data, and we found some interesting things. So if you'd like, I'd be happy to show a few slides. Okay. Doesn't seem to be loading up. Oh, okay, terrific. So I'll pick a slide then. Terrific, thank you. Okay. Terrific. So this is some of the data that we've been collecting over the last few years. So this is this is Stephen and me at the Met in New York. And in fact, it was pretty funny, actually, because I wasn't going to go to this meeting. I guess I have a really good track record at offending, luminaries such as Francis Crick and Stephen Hawking and so on. But I was invited to hang out with Stephen at the Met, and I thought, well, I have this little company I have to really go back to, and I thought he would be giving a speech, and perhaps there wouldn't be time to communicate. And I didn't realize that there would be a handful of people. So it's funny how life works, because I shared a cab ride with someone after one of the events. This was for the World Science Organization, World Science Festival in New York. And as I was dropping off this gentleman in New York and about to go back to my hotel, I thought to myself, he's so pretentious, this other person. He was name dropping left and right. And as I was packing my bags, I just thought to myself, maybe I should reevaluate. Maybe what this gentleman was telling me was that he was feeling very fortunate that he had the opportunities to interact with a lot of very brilliant people. And I thought, I was reading Stephen's books when I was a teenager. Maybe I have time for him. So I did show up at the Met, and I was glad that I did. And this is how this friendship began. So this is now about a year later. This is Stephen wearing the device. And on the left, you have Luke. On the right, Helena. Luke is an MD PhD from Hopkins and from Cambridge. Helena, her work was on the cover of Science when she was 14 years old. She's from Oxford. And I sent them to see Stephen to do a longer recording. And Stephen generously wrote a letter to explain that, in fact, he was getting on the record to really be a subject in a clinical trial. We have since then started a clinical trial in Philadelphia with ALS sufferers. And here we have other gentlemen from Florida and from the Max Planck Institute, and we pretty much gave up our holidays and analyzed this data that was recorded in Cambridge. And so on the left-hand side, so let me explain to you what this looks like. Don't be overwhelmed. There's just some pretty pictures. But so, one of the greatest inventions, I think, that humanity has come up with is the Fourier Transform. It sounds a little nerdy, but it's true. And what it is that it is a mathematical formula that enables us to see the frequency content in some information. So for example, let's say that we start playing music here tonight, and we wanted to look at the frequency content, the high frequencies maybe from a violin, or the low frequencies from a trombone. We could use a Fourier analysis to do that. And the way we would plot this is the following. On the top left here, you have time on this x-axis, and then you have these frequencies that are all stacked up against the other. The low frequencies are at the bottom, the high frequencies are up on top. And the idea is that if something has a lot of information at low frequencies, you're going to see these more vibrant colors there, and if you have more information at high frequencies, that's where they will be. Okay. Does that make any sense, or should I spend a bit more time on that? Make sense? Okay. So basically on the left side, we have a traditional analysis. And on top, Stephen is not doing anything in particular. And on the bottom, he's imagining that he can move his right hand. He can't move his right hand. But you can see that if we do a traditional analysis, it appears that most of the information is at these very low frequencies. On the right side, this is with our own proprietary algorithms. We can see that, in fact, we're detecting activity at much higher frequencies. Something is happening, even though Stephen is not moving. So here's a different way of looking at it. On the top left, Stephen is imagining that he can move his left hand. And what you see in blue is sort of our detector. So when you see a spike, it means that we've detected something. Now, the green bar is when we are asking Stephen to imagine that he can move. The red bar is when we ask him to stop imagining that. You'll notice that most of the spikes are exactly between green and red. That's pretty amazing, because what it means is that he's trying to move his left hand, his right hand, his left foot, his right foot, and we are detecting that. But there has not been any movement. So this is Calvin, another wonderful, actually, intern from Britain. And we redid these analysis, and you can see how sharp this is now between green and red. You can see these very strong peaks. Now, Stephen is actually opening and closing his eyes, and here he's imagining that he can squeeze his right hand, his left foot, his right foot, and his left hand. It's mesmerizing. Mm-hmm. Because what it means is that if the signatures are different enough, in other words, if we have not only high sensitivity, but high specificity, we should be able to enable a person to communicate by imagining that they can select letters, right? By imagining that they can move. And it also means that for those people who suffer from paralysis, because they may have a severe spinal cord, that one could actually feed these types of signals to an exoskeleton that would then move limbs for them. So this is very exciting. This is the tip of the iceberg. This gentleman is Ogniero. He founded a company called Life Fitness, and when I had met him, he had been battling ALS for 8 years. He had this Barber type, so he was communicating by moving his feet and selecting words with his feet. He was moving a mouse with his feet. He had about 40 words a minute on his feet, so I guess you could say he was pretty quick on his feet. And so this is he was interested in the project, and this is a short video about the project.
Augie Nieto is a fitness industry entrepreneur. In 2005, he was diagnosed with ALS and soon became almost completely paralyzed. The only parts of his body he can move are his feet. He uses them to control a speech computer. Even these muscles will eventually degenerate. But he may not lose the ability to communicate. Neurotechnology pioneer Dr. Philip Lowe is hoping to hack into Augie's mind before it's too late. Philip and a team of engineers are building a state-of-the-art brain reader, a device they call the iBrain.
I'm wearing, the first portable brain monitor ever built. And what it is doing is that it is recording my brain data. It is actually sending it over to our servers, and our algorithms can crunch on it.
Every time we decide to move our muscles, billions of neurons fire miniature bolts of electricity inside our
These
brains.
are called spikes.
Philip's electrically sensitive eye brain can detect these electrical pulses by measuring the small changes in voltage they produce on the surface of the scalp.
Which are the brain waves. By seeing the activation of particular brain structures, we can tell, this person is trying to move his hands.
Philip thought the eye brain might help patients like Augie, who, despite their paralysis, have healthy, functioning brains that can still send signals to their muscles.
ALS patients do not have problems when it comes to their own brains. The areas that his brain is using in order to control these limbs, these areas are still working perfectly fine. They're just unemployed right now. Hi, Augie. Nice to see you again.
If the eye brain can pick up Augie's mental intention to move, Philip could create a new means for him to communicate.
You will have a prompt that will ask you to imagine to move your right hand for 4 seconds at a time. And of course, we're going to be monitoring your brainwaves very, very closely during that time and having all our algorithms crunch the data in the background as well.
The test is successful. Philip's eye brain recognizes whenever Augie is thinking about moving his right or left hand.
Augie had a very successful first test. We will use these brain patterns in order to control a virtual hand on the screen, which will enable him to just pick these words and pick these letters and enable him to communicate. So this gives us a lot of hope and encouragement that in fact we have a system that will work for everybody and that will enable individuals to use their brain patterns in order to communicate.
The biggest fear for someone with ALS is to be not able to communicate. That is called being locked in. With the eye brain, I will never be locked in.
So Augie actually did spell. And this was the first word that he spelled, communicate. This was about a year later. So again, this is still in its infancy, and we still have to accelerate the whole thing, but it's a start. I have another example of Augie communicating actually with iBrain 2, but perhaps in the interest of time, I'm watching the clock here.
Yeah.
We can come back to it afterwards.
That's fascinating, and thank you for all that you're doing for ALS patients and Alzheimer's and we didn't even talk about PTSD patients. Tremendous strides. Follow Philip and you'll learn more and more. I really wanted to talk about animals as well. Animals are close to Philip's heart, and he's studied them with the eye brain as well. So why don't you talk about what you've discovered with studying the brains of animals? And
Sure. So this algorithm that I invented to sort of look at brain activity, I initially used it on birds. And this was sort of very interesting to look at them because their brain structure is completely different than that of mammals. So let me just quickly show you some slides. This was finches, zebra finches. Okay. So if we look at brain weight, humans don't have the biggest brains. We don't. We don't act as if we do, and we really don't. So a lot of people said, well, maybe that's true, but well, let me put it this way: which brain here is the human brain?
Right.
Which one is on the left? Dolphins. Dolphins. This is a dolphin brain on the left. This is a human brain on the right. It's pretty amazing. Orca left, human right. Here, this is a whale on the left, human on the right. And then, basically, and now we have elephants, gorillas, etc. We don't have the biggest brains. And so people said, well, that's not a problem. If we just divide our brain mass by our body mass, then surely we'll be on top. Turns out that's not true. We have, it turns out that the ratio of brain to body is 1 in 10 for the shrew, 1 in 12 for small birds, and 1 to 40 for humans. Well, then people said, well, that doesn't matter. Maybe we can come up with another metric to put humans ahead. So they said, well, let's look at EQ. Okay, well, what is EQ? Not emotional quotient here, but encephalization quotient. And the idea is, how big the brain would you expect this animal to be for his or particular size? In other words, and if it turns out that this animal has a brain that's much bigger, it has a high EQ. So you can see that if one uses a metric like that, the blue whale is very disappointing when it comes to EQ, and dolphins are actually more satisfying. But it turns out that that's not very. This whole argument is not satisfying because the number of degrees of freedom to operate a big body is not significantly different than the degrees of freedom that you need to operate a smaller body. So people said, okay, hang on. So maybe there's a different argument to put humans ahead. It turns out that we recognize ourselves in the mirror. Perfect. Okay. Elephants recognize themselves in the mirror. And dolphins recognize themselves in the mirror. In fact, if you pretend to mark a dolphin with a mark, and the dolphin is actually not marked, he will swim to a mirror, and he will make all kinds of very unusual movements to really check himself out and see where that mark is. And oh yes, so this is with the EQ thing. Okay, so people said, okay, well, it's thanks to these cells, the spindle cells, also known as von Economo neurons. And they have them, we have them, so we're part of this elite. There's only one problem. There's another animal that recognizes itself in the mirror, and this animal doesn't have these neurons. Anybody has an idea? Yes, magpies. Magpies. In fact, magpies, yeah, magpies. And in fact, they will, they're very smart. I mean, they will actually hide their stash. Do you know when? Not because anybody has stolen their stuff. It is because if they intend to steal, they will move their stuff around first, as if they are anticipating retaliation. So they don't have this. And in fact, they don't even have a neocortex. And so in my work, I showed that finches had brain patterns that were extremely similar to those of mammals. And in fact, there were particular brain patterns, such as the one on the lower left called the K-complex. So we've got voltage over time here. We're looking at 3 seconds. These things have been seen in the cortex before. They've been seen in humans. So in the middle here, you have a human K-complex. But they were always attributed to the cortex. Here, if we look at low frequencies on top and high frequencies from the same brainwave, you see that when the low frequencies are high, the high frequencies are low. When the low frequencies are low, the high frequencies are high. These are called the up and down states. They were seen in cats, but in the cortex. And here we're seeing them in these little Tweety birds. So that completely spoils all these different arguments that we've heard about sort of, all these excuses that we make to put ourselves ahead, because a Tweety bird with a brain the size of a peanut can produce the most evolutionary advanced brain patterns without the most evolutionary advanced brain structures. This led to the Cambridge Declaration. I have the original here. And it was the first time the neuroscientists from all over the world came together in Cambridge, England, and pretty much rebuked the Cartesian hypothesis or assumption that we were so special that Descartes saw that pretty much humans were the only animals with a soul. And of course, the modern interpretation of that would be that we're the only animals with consciousness. If we look at these different brains and we ask ourselves dispassionately, just by looking at the microcircuitry, the neurophysiology, and the behavior, is there continuity? It turns out that there's tremendous continuity. And even in animals that have a different brain organization, such as birds or the octopus, we see that there's a tremendous overlap in terms of how they can react. An octopus is able to abstract, for example, an image of a prey. And by the way, going back to the dolphins, they are able to actually communicate symbolically. They can actually assign particular value to their communications. So that ended up being a change, and this was done in Cambridge, in this room. And Stephen Hawking was, again, the guest of honor. And the people who signed his declaration did this at huge personal risk and personal cost, because they were risking their entire reputations and pretty much their income, because they were saying something that their department chairs didn't want them to say. So it happened, and I have the original here.
And also, I think that you've also talked about farm animals as well, right?
Well, absolutely. So, one of the very interesting reactions to this declaration, and this is, as I said, this is the original. It's all here. And so after this first declaration, I went to Brazil and decided to do it again. But now with veterinarians over there. And so we have this other document called the Curitiba Declaration. It's actually written in Portuguese. And it pretty much says animals are not things, they're sentient beings, and accordingly they should not be treated as things. Under Brazilian law, there's no difference between a piece of furniture and an animal. And that is true also in the EU, and we still have a lot of work to do in America. I had this signed by the leading veterinarians in Brazil, including by a dog, who was a seeing eye dog, and who worked for the federal government, so I thought it was particularly fitting. So the responses that we got were, well, one response was, "Da." And my response to "da" is, "Okay, so you knew this." And people will say, "Anybody with a dog knows this." Okay, well, that's great. Now at least we have as Mark calls it, a cautionary warning about these facile assumptions that people have been making. But what about a pig? Why would you eat a pig and pet a dog? Why would you eat a cow and pet a dog? These brains are complex brains. We kill in this country, so one of the reasons I went vegan is because in this country, as we've moved from farm to factory farming, we destroy, the egg industry destroys 200 million male chicks, and they throw them in a wood chipper. And they give this process a name, and by giving it a name, they sort of sanitize it. They call it maceration. But these are complex brains that we are just destroying. And so my sense is, yes, fine. So you knew that. You knew that your dog was really happy to see you. Mazel tov. But then be consistent. Either admit that you're being hypocritical or end the hypocrisy. It's easy for us to lecture the Chinese about not eating dogs. But then they'll say, well, what are you doing to pigs and to cows? And I think, unfortunately, they have a point.
Right. And I think also who saw Raising Extinction at Sundance? Anybody? Okay, so I think Louis Sohoyos made a good point in the film, which is cows, for our own consumption, create more methane gas, which contributes a greater amount to a greenhouse effect than CO2 does, which is interesting. I think that another thing that's interesting here too in Park City, and I think that she'll raise her hand later, We have something in Park City now developed by Lauren Lockheed and Dave Schwartz, and it's called the Mountain Sage Animal Rescue Center, and it's going to be in Browns Canyon starting in the summer, where they're literally rescuing animal, wildlife, and farm animals, and have a sanctuary for them. So I thought that that was a pretty cool step, and you had never heard of that before.
No, and I think they deserve a big round of applause.
Yeah, so let's stand there. Yeah. So before we go to Q&A, I'm going to skip a couple of these. If you have unlimited resources with all of your experience and the technology that you know, what would you like to achieve in your lifetime, which would be your ultimate dream?
So, you know, it's even strange for me to be here. It's wonderful, but it's strange because I was always the kid people were about to fire. So now I'm at fire. But I mean, to give you an example, I only found out years after my PhD why they hadn't fired me. They were going to do it, and a philanthropist who's very interested in neuroscience called them and said, "Don't touch Philip. I'm paying for his whole PhD. He never has to know that I'm doing that. Let him do what he needs to do, because he asks questions that bother everybody, and that's what we need." So I was very touched when I found out, you know, years afterwards that this had happened. But the point is, I'm always I usually am the one who is so close to the edge that I make a lot of people, including in my personal circle, very, very uncomfortable. And if I don't do that, then I feel that I'm not living, because that is where the contributions can really be made. So I think one of the dangers that one faces is, you know, if one has been lucky, so with Spears, with iBrain, there's some promising initial things now with the ALS project. There is a possibility of getting too comfortable and not being hungry for change. So, you know, it's a very, very important question, the one you ask. And my initial answer would be, you know, I would like to keep being a troublemaker, but I know that it's not going to be satisfying to you.
No, not at all.
So I do think that, you know, if we look at the history of you know, cosmology, for example, and astronomy and so on, we have had this human hubris of always putting ourselves first. This was always the status quo. You know, okay, so maybe we're not, you know, maybe our galaxy is not the center of the universe, but sure enough, we're the center of the galaxy. Okay, maybe not, but surely enough, you know, the sun orbits around us. Well, maybe not. Maybe we're just this little pale blue dot orbiting around the stars somewhere, you know, on the edge of the Milky Way. And when it comes to biology, when it comes to neuroscience, we are in this pre-Copernican era. We have committed this hubris again by thinking that because we have this great potential for creation, that the Earth is there for us, and we can pillage it left and right. We unfortunately have a great potential for destruction as well. And many of the species have figured out how to live together. We haven't. I'm not sure we're that smart, given the amount of neurobiological capital that we have. So, you know, I will die happy because of this. Not because I wrote it, but because it happened in my lifetime. But I would love for humanity to not depend on animals anymore, and not depend on their suffering, not subjugate them anymore. There's a big difference between having companions and having slaves. And I'll tell you something very quickly that I may not have shared in some private conversations. Two things, and I'll be very quick because I know there may be some questions. The first was, many years ago, I asked 3 eminent neuroscientists the same question. Are animals conscious? If they are, do we have a right to use them? If they're not, why do we anesthetize them? One eminent neuroscientist said, Philip, this is a political issue, just don't worry about it. We've got lobbyists for that. All right. Another eminent neuroscientist had a more practical approach. He said, you know, we anesthetize them because we don't want them to move when we do a surgery. And we also don't want to think that we are creating pain. So it's for our own selfish purposes that we anesthetize them. And then the third one said, we anesthetize them because they're conscious. And they wouldn't be able to feel pain if they were not conscious. And we will be remembered very unfavorably in the future. And I was stunned by that admission. This was a gentleman who worked with monkeys. And my sense is that there is a time now and an urgency for transparency. And to the extent that I can lay my small brick and help some of the world's biggest pharmaceutical companies conduct clinical trials without killing 100 million vertebrates, wasting $40 billion per year, and having a probability of testing a drug in an animal of being less than 6%, then that would be a nice little brick.
Thank you. We'll open this up for Q&A now. So I think we should bring the lights up if we can and open up for Q&A. Okay, there we go.
I've got the first question. Hang on.
Thank you. I'm Lauren Lockey, and this is Dave Swartz, and we are the founders of Sage Mountain Animal Rescue. And
Thank you for what you do.
thank you for what you do. I'm just amazed and so grateful. And we have a farm animal rescue that we have out in Browns Canyon. And everything that you spoke about is why we have founded this organization. And not only the impact on the animals, but also the environmental impact as well is huge. You touched on it, Sharon, and thank you so much for this. About the emissions to greenhouse gas that is gigantic. It's responsible for 51% globally, just animal agriculture. So anyways, long story short, please check us out. We are on the internet, and we're working to build awareness about these animals as sentient beings, as well as the environmental impact animal agriculture has, and the health as well of consuming animals. So thank you so much, and I hope to talk to you tomorrow.
Sure, thank you very much.
Sage Mountain Animal Rescue.
Yes.
Just one thing, if I may. You've just reminded me of something that I think might be relevant here for this audience. I had the pleasure of meeting a state Supreme Court justice at the MacArthur Foundation in Chicago. And he saw this declaration, and he said, I want every member of the audience to have a copy. I was a little stunned. He seemed a little portly. It seemed like he enjoyed his steak, you know. I was a little taken aback by this. And so I said, well, you know, people will still always love their steaks. And he said, you know, they use a time when people love to have their slaves too. And I said, where are you going with this, Your Honor? And he told me two things that I was very, very, very surprised to hear. The first one was the following. He said, you know, a court has some latitude when it makes a ruling. If you're telling me now that some eminent neuroscientists, and the other guys are, and ladies, have come together and recognized this, this is huge because it means that in my court, I can decide that an animal has not been treated fairly, and I have some latitude I can say that it changes, I think he called this the rules of decency. I thought that was very interesting. And then he said this, he said, do you know that the US Constitution was not written for humans? And then I thought that maybe, you know, he was a little poorly not because of the steaks, but because of the booze. And I said, but Your Honor, it was written by humans for humans. He said, no. It was written by humans for people. And he said, we care about unborn fetuses because we think they're people, or they have the potential to be people. If you're saying that adult animals have brains that are more complex than those of, you know, human fetuses in the third term or toddlers, then they may actually have rights under the US Constitution. I thought about this. It turns out that India has recognized dolphins as people. One is not allowed to kidnap them and put them in delphinariums. One is not able to actually interfere with their culture. Their culture has been recognized. Colombia has banned the use of elephants as circus animals. There is a global awareness that is starting. Unfortunately, America is not leading the debate. And I feel that many people in this audience have been very privileged to attend the events that Shannon and Mark organize, and people with tremendous influence. And I find it rather sad that the most technologically advanced country in the world is not leading on this.
Okay, next one. Are you okay with running over for 10 minutes? Okay.
Sorry to go over.
You have these sensors that you put on people's brain. Have you looked at any people when end of life come?
Great questions. We have not, but we will, because next year we are starting a rollout of 20,000 units, and instead of asking people to join particular very regimented, situation, we will be able to monitor them at home and in hospices and so on. And we absolutely want to provide assistance in terms of collecting valuable data. We don't have that data yet, but we are going to be collecting that data.
Go ahead, as long as you're...
Microphone. I've got two items I'd like you to make a comment on. One is brain-derived neurotropic factor as it affects plasticity in older people. And the second thing is the amount of brain cells that are in our lower gut, which is kind of coming to the forefront now. I've been reading about it for quite some time. Could you comment on the effect of that brain process that's actually in your stomach plus the brain-derived neurotropic factor?
The biome. We're talking about the biome.
Sure. So BDNF is a growth factor, and it can be stimulated by actually exercise. It can drive neurogenesis. So neurogenesis is when we add more cells to our brain, and BDNF is a very important part of that. The area which is affected by Alzheimer's, the hippocampus, can actually generate new cells, and BDNF is a component. It turns out that exercise, mental stimulation, and antidepressants can be drivers here.
Fasting. Reported to do it also.
I haven't seen that paper, but I'd be happy to look at it. The interesting thing here is, it reminds me of another point, a little similar to previous question. It turns out there was a landmark study, by the way, last summer, which showed that during sleep, the morphology of our neurons is actually changing, and glia cells, the helper cells, are pumping cerebrospinal fluid through the brain, and it's possible that we're actually evacuating some junk, during sleep, and that the link between poor sleep and Alzheimer's is more than correlation. But that's a little bit of an aside. I don't know much about the gut. I wish I could tell you more, but I think in the interest of time, we can.
Your nervous system.
Yes,
EMT.
yes, sure. But in terms of, I wouldn't call it a brain in the gut. I think it's a nice way of calling it. But I wouldn't say that it necessarily does decisions. But I'm happy to talk to you about this on the side.
So let's take 2 more questions, and then actually we can all join each other over. We'll tell you where to go. In a nice way.
What is your position on fish, insects, and for that matter, C. elegans? How far down do you go?
Great question.
And if this is a moral issue, should we be looking down?
Great question. Thank you very much for asking it. That was something that was debated hotly behind the scenes in Cambridge. And there were some people who said fish have to be on this because they actually have, they will produce endorphins, for example. They seem to also have pain receptors. But there is necessary and there's sufficient. What we did was the following. We decided to leave the door open, which is why the declaration says, and many other creatures, but we only made a positive statement about data that was presented at the Francis Crick Memorial Conference. We did not have fish experts there, so we did leave the door open, but where we did have a consensus was, at the level of mammals, of birds, and even the octopus. But I agree, I think that it is a very important topic. And in my case, I decided, to just not touch that either. But I think it is important and worthy of consideration.
Mm-hmm. One more?
You looked at comatose patients?
Yes.
2 more. You snuck that in.
We looked at comatose patients. We actually created an entire system for comatose patients. We were involved in the Jai McMath case. I don't know if some of you are familiar with this case. And I actually spoke, so this was a young lady in Oakland who was going to be removed from life support. And one of the arguments to make that choice was that her EEG was flat. And I said, but if she had brain hemorrhage, that would increase the impedance, in other words, on the brain, and it would be much more difficult to actually read a signal. So apparently some of my comments were relayed to the judge, and this was part of many other comments, of course. And I don't have a clear confirmation of that, but this is what I was told. And she was actually not terminated, and she's alive now and showing some signs of recovery. We were asked by the government of Israel to work with Al Sharon, and we had created again a system for him to see if he could again imagine that he was moving, to tell us that in fact there was something there, but unfortunately he passed. We do have a system in place, but we haven't deployed it widely. We would like to.
Thank you. Okay, last one.
You're described as someone with strong intuition. Have you tried to quantify it, and where do you think it resides?
Maybe in my gut.
And on that note,